In the last couple of videos we have introduced the concept of the atomic mass and the concept of the mole. In this video we talk about how the concept of the mole extends beyond atoms to molecules, and then we talk about the molar mass. Alright, so when we actually do chemistry in the laboratory, it's very uncommon that we use individual atoms to run reactions. Instead, most chemical reactions, particularly those that are done with solids or substances in solution, actually are never going to have individual atoms separated. Instead, the atoms are going to be forming part of molecules. So it's important to understand how the concept of the mole extends naturally to molecules. Right, so there's actually nothing mysterious about it. The concept still applies. So if we take water as an example of a molecule, we will have that 1 mole of water will contain exactly an Avogadro number of molecules of water. Okay, instead of atoms, we now use molecules as the atomic level entities that we're talking about. Right, so from there we can then go on and try to calculate what will be the mass of 1 mole of a molecule. Okay, so if we take again water, okay, 1 mole of water, the question would be, well, what is the mass then of 1 mole of water? Because the molar mass is again one of the bridges that we have to use to connect the atomic world or the molecular world with the macroscopic world, the one where we live in. Right, so what we actually then notice here is that every mole of water contains 2 moles of H and then 1 mole of oxygen. Okay, and notice that because the mole always contains the same number of entities, okay, this also happens at the atomic level. Okay, so we have that this conversion is exactly the same in the atomic level, right? So 1 molecule of H2O, water, contains 2 atoms of H and then 1 atom of oxygen. Right, so obtaining the mass of 1 molecule of water would be straightforward. You just take the atomic masses of 2 atoms of hydrogen and then 1 atom of oxygen, and then calculating the molar mass or the mass of 1 mole of water. We just need to take the mass of 2 moles of hydrogen atoms and then 1 mole of oxygen atoms, and then add that up, and that is exactly what we're going to do. Okay, so 2 moles of H atom would be 2 times the mass of 1 mole of H atoms, which is 1.008. You go to the periodic table and you get that that is the mass of 1 mole of H, hydrogen, and then 1 mole of oxygen will be equal to 15.999 grams. Okay, so you add all this up and you find that the mass of 1 mole of water is equal to 18.015 grams. Okay, and that is what we call the molar mass. Now, we can continue to do problems now that we have the molar mass of various mineral substances, and we're going to close this video by doing a calculation in which we take a macroscopic sample of water, and then using the concept of the mole, we calculate how many molecules of water we have in that particular sample. Okay, so the size of our sample is going to be a glass of water, and the problem here is that the glass of water, the unit to measure the capacity in a glass of water is actually volume, not mass. So we're going to have one more transformation than we have had in prior problems. Again, the goal here is to calculate how many molecules of water you have in 1 regular glass of liquid water. All right, so let's do that. Again, we have that 1 glass happens to be 250 milliliters of liquid water. Okay. Now, again, we actually need here something to do with grams, because the concept of the mole and the molar mass, they entail mass, not volume. Well, the magnitude that relates mass to volume is the density, and we know that for water, you actually have 1 gram per milliliter. Okay, this conversion is exact, more or less at around room temperature. Okay, so what we actually go here is transform milliliters to grams, and then we have that 1 glass of water contains 150 grams. From here, we actually then can continue and do our mole calculations to figure out how many molecules we have in that particular glass of water. Okay, so 250 grams of water. And the first thing that we do is convert it to moles. Okay, again, as usual here, the bridge is going to be mass, to go to mole, to go to molecules, in this case, or atoms. Okay, the important thing here is that, again, we're bridging here the microscopic world to the microscopic world, the world of atoms and molecules. Right, so the first thing is to calculate the number of moles here, and again, we can do that with the molar mass, right? So notice that 250 grams of water is going to be equal, when we transform it to moles, we have that in each mole, we actually have 18.015 grams of H2O. Okay, so this conversion will give us here how many moles of water we have in that glass of liquid water, but we also know that in each mole that we have, there is an Avogadro number of molecules of water. Per 1 mole. Okay, so when we do this calculation, in the end, we found that this number is equal to 8.4 10 to the 24 molecules. 24 molecules of H2O. Okay, now we could continue to work with this problem, and then from here figure out how many atoms of hydrogen we have in that glass of water and how many atoms of oxygen we have, and for that we simply take a look at the molecule of water, right? So in each molecule we have 2 atoms of hydrogen, 1 atom of oxygen, so that means that in this much volume, in this glass of water, we're actually going to have this number of atoms of oxygen and twice this number the atoms of hydrogen. Okay, so hopefully with this video we have introduced the concept of molar mass, which is going to play a pivotal role, an essential role in this chapter and in the rest of this general chemistry course. Okay, and you can see an application for why this is going to be important.